Okay, let's go ahead and get started. If anybody is in the stream and has not already told me that they're there, please be sure to just type a message or something, let me know you're here so I can get you on roll. All right. So, we've been talking about functions. Thank you, Isabel. Isabella, sorry. We've been talking about functions. And something that I had mentioned is that we can compose functions together. Something like if we have f of x equals 2x, and g of x equals x plus 2. We can compose these functions together using f composed of g of x, or the other way around, g composed of f of x. So what we're saying here is, like for f composed of g, we're going to take f, the 2x thing, and then where we have this x, we're going to plug in g of x. So, for instance, this one, you might say 2x, and then instead of writing down x, open up a set of parentheses so that you can plug things in. Thank you, Isaac. So again, we have f of x, it's 2x, we have 2x. And then into here, for our x, we're going to plug in g, so x plus 2 is going to go right in here. And we can simplify that, of course. Just 2 times this would be f composed of g of x equals, 2 times x is 2x, 2 times 2 is 4. So there would be the f composed of g. Like I said, we can go the other way around as well. We can do g composed of f. So same idea. We're going to take this thing, but instead of writing x, we're going to write some parentheses. And these parentheses are what we're going to plug this function into. So 2x is going to go in there. So if we go ahead and simplify this, this would be g composed of f of x equals, let's see, well, we don't really need those parentheses, so just 2x plus 2. And this is something important here. We can compose functions of each other, so we can plug either f into g or g into f, but they do not always give us the same thing. The order in which we plug them in matters. So like if we plug g into f, we get 2x plus 4. If we plug f into g, we get 2x plus 2. So they're different. Now, this isn't the only way to put functions together. So we can plug one function into another one, but we can do some, I guess it's a little bit more complicated, but not really. We can do things like f minus g of x. We can do things like f plus g of x. We can do f times g, f divided by g, all that kind of stuff, and vice versa. We can flip it the other way around as well. So let's take a look at that real quick. Let's start with f plus g. Now, let's say we have two functions, f and g, but we don't know what the actual rules for the functions look like. So we don't know what that is. Maybe we have f of negative 2 equals negative 2. So we know that if we plug in a negative 2 into our f, it gives us out a negative 2. We don't know what the actual structure of f looks like, but we know if we plug that in, we get a negative 2 out. And then maybe g is something similar. If we plug in a negative 2 for g, maybe we get 4 out. Okay. Well, if we want to do f plus g of x, something we might be able to do is say, all right, if we know negative 2 for both of them, then we can say f plus g of negative 2. Well, that would just be where we take the value for that, negative 2, and the value for that, 4, and add them. So what did we get for f? We got negative 2. What did we get for g? We got 4. Put them together. So negative 2 plus 4 is positive 2. Okay. In a similar way, we could go and say f minus g of negative 2. Same thing. What did we get for f when we plugged in negative 2? We got negative 2. What did we get for g when we plugged in negative 2? We got 4. So this would be negative 2 for f minus 4 for g. So negative 2 minus 4, that's negative 6. Multiply f times g. Well, again, since the negative 2 is the only part that we know, f times g, so this one times this one, negative 2 times positive 4 is negative 8. And why not round it out with f over g of negative 2. So what do we get here? Negative 2, here 4. So negative 2 divided by 4 is negative 1/2. Okay? The idea here is that when we're doing f plus g or f minus g or f times g, really what's going on is we're taking the value of f and, like adding it to the value of g, or subtracting the value of g from it, or multiplying it by the value of g, or dividing it by the value of g. Okay, so it's the overall value of this and the overall value of this. So even if we don't know the actual mechanics behind f and g, we can still figure some stuff out if we know some data points. Now, let's say we have our original functions again. F of x is 2x, and g of x is x plus 2. So let me write these back down here. F of x is 2x, and g of x is x plus 2. I do have the structures for these. I have the rules for what G is and for what F is. And so if I wanted to do something like F plus G of X, again, really all it is take the overall value of this and add, in this case, add the overall value of this. So what's the value of this? 2x. What's the value of this? X plus 2. So plus x plus 2. And then simplify. Well, here we don't need the parentheses, so if we simplify this one down, we get f plus g of x. Let's see, 2x plus x is 3x plus 2. Okay. Any questions? Okay. While we're thinking of some questions, I'm going to also do minus. So f minus g. So let's see. Just like this one, the only thing that is different is that instead of adding these, we're subtracting them. All right. So once again, don't really need the parentheses except for right here. Distribute that negative into here. That makes that negative x and negative 2. So 2x minus x is x minus 2. Did we come up with any questions? Does not look like it. Okay. So here's a sort of a bonus question that you might see on a quiz. Hint, hint. F plus g. We know that if we compose functions of each other, they usually are not the same outcome. So like f composed of g, it comes out to be this. G composed of f comes out to be this. They're different. So what about adding and subtracting these things? If I did g plus f instead, would it come out to be something else? How about f minus g? If I did g minus f instead, would I get something else? This comes down to our properties of addition. Okay? So one of the properties of addition says that it really does not matter which way we add things. We could have 2x plus x plus 2, and it would come out to be this. Or we could have x plus 2 plus 2x the other way around, in other words, g plus f, and it would still come out to be this, because it does not matter if you add 2 plus 5 or 5 plus 2, they're the same thing. What does start to matter is subtraction. 2 minus 5 is not the same thing as 5 minus 2. So here we can say that if we get f plus g, and it comes out to be this, that would be the same as g plus f. However, when we're subtracting, we can't say the same thing. F minus g is going to come out to be, in this case, x minus 2, but what's it going to be if we do g minus f? Let's see. So g minus f of x equals, or g is x plus 2 minus our f is 2x. That makes this negative 2x. Okay, so what do we get here? X minus 2x is negative x plus 2. Similar, but their signs are absolutely opposite. So again, any questions? And while we're coming up with questions, I'm going to set up the next one. Okay, doesn't look like we have any questions, so I'll move on. And of course, if you do come up with a question, don't hesitate to just type it in the chat and I'll get to it. All right, so we did add and subtract. Let's try multiply and divide now. Same idea though. We're going to take the entire value of f and multiply it by the value of g. So 2x times the value of g is x plus 2. So we're going to multiply them. Well, is it going to be any different for the other way around, g times f? Let's think about it real quick. Again, we have x plus 2 for g. We're going to multiply that by 2x for f. Well, no, they're not going to come out any different, are they? Because just like with our properties of addition, multiplication doesn't care about order either. We could have 2 times 5, that's 10, or 5 times 2, that's still 10. They're the same. So both of these will come out to be the exact same thing. So really we only need to worry about one. Okay, so we've got 2x times x plus 2, meaning we need to distribute 2x into this set of parentheses. So 2x times x is 2x squared. And then 2x times 2 is 4x. And like I said, f times g and g times f would come out to have the same exact thing. So this one would also be 2x squared plus 4x. Okay. How about divide? So f over g of x versus g over f of x. Okay, Well, in this case, there will be a difference for sure. And like with subtraction where order matters, order also matters in division. 10 divided by 5 is 2. 10 divided by 2 is 5. They're different. Okay. So here we have f over g. We're going to do that exact same 2x f over x plus 2g. And that's about as far as we can go. There's not really any simplifying we can do. So on the other side, g over f, let's see what this looks like. X plus 2 over 2x. Yeah, same thing. Can't really simplify it. But for the practice here, let's remember that we have a problem with these. Both of them. We have fractions, and in the denominator of both of these fractions, in fact, there is an x present, which means that there's something that we could plug in for x to make this bottom part 0. And thus, each of these has their own domain restriction. So we need to say, all right, hold on. If we want to be complete about this, the bottom part, x plus 2, cannot be equal to 0. Meaning that x cannot be equal to negative 2. This one over here, same deal. We want to say the bottom part, 2x, cannot be equal to 0, meaning that x cannot be equal to 0. So even their domains are different. Okay, so what questions do we have? Again, be thinking about questions as I set up the next one. Okay, doesn't look like we have any questions. So to end off today, let's go ahead and see what graphs of these look like. It's quite dark. Yeah, seems like that's about as good as I'm going to be able to get right now. Whoops. Okay, so I have our f of x and our g of x plugged into here. And let's go ahead and compare them. Okay, So again, f of x is the blue one, g of x is the red one. Let's see what happens when we add them together. So remember that when we added them, we got 3x plus 2. Okay? So, not really a whole lot we can tell from it, but it does modify this graph quite a lot. So this is a combination of the two. Now, what does it mean when it crosses the other lines? Let's take a look. So what we're looking for is where they are exactly the same. This is just a list of the x values that we're plugging in. This is the y value that we get out for our f of x, the y value we get out for g of x, and the y value we get out for f plus g of x. Okay? Well, first of all, as we can see, this is literally f plus g is this. Negative 6 plus negative 1 is negative 7. Negative 4 plus 0 is negative 4. So it's literally f plus g. We can see that in the data here. Okay. So, graph and then trace that. So I'm seeing a crossover right here, and then another one right here. I wonder if those do anything. So that's 0 and 2. So if x equals 0, this one is 2, and that one's 2. Good, all right. Interesting. All right, let's take a look at the others. So how about f minus g? Now, these came out to two different things. F minus g was x minus 2, and g minus f was negative x plus 2. So there's our f and g. Okay. So we've got, again, this is our f minus g, which was x minus 2. This is our our g minus f, which is negative x plus 2. Real quick, I'm going to take these off so that we can see something interesting about these two. Lines look similar, don't they? But they're in opposite directions. There's a axis of symmetry running here and here. So they're very similar, but it's almost like they've been flipped. In fact, yeah, this one, this is our f plus g. I'm sorry, this is our f minus g. We get negative 5. Over here we get 5. Negative 4, 4. Negative 3, 3. Negative 2, 2. Negative 1, 1. They're the exact same, but the sign on our y value is flipped. So very interesting, very interesting. Let's try some others. Okay, I'm going to put the originals back in, 2x and x plus 2. And then let's try our multiply. So when we multiply these two functions, we get 2x squared. Where's my square? Yeah, I'll just do it like that. 2x squared plus 4x. completely different, isn't it? Okay. And it's the same for both of them. Both of them are going to be that. What about when we divide them? So our f divided by g is 2x divided by x plus 2. Okay. And then our other one was the exact opposite. X plus 2 divided by 2x. All right, let's get rid of those first two so we can see this a bit more clearly. Yeah, the negatives when we were subtracting, so f minus g and g minus f, they looked like opposites. They looked like what we would call inverse. So what about these? Did they make inverses? No, this is not an inverse. Remember what I mean by inverse is that the x's and y's have been flipped. That's because just changing the f and the x, which order you put them in, does not give you an inverse. That's something that I've kind of noticed. Seems like some of us believe. But an inverse comes from something completely different. So I want to go back over that real quick. So for instance, we got f over g of x equals 2x over x plus 2. Well, what's its inverse? Okay, well, to find the inverse, first of all, let's make this y instead, since it's easier to write. And like I said, an inverse is literally flip your x and y's, change their position. So we're going to do that right here. This becomes x equals 2y over y plus 2. And now we want to solve for y. Okay, well, that fraction's kind of annoying me, so I want to get rid of this fraction. So I'll multiply by y plus 2 on both sides to get rid of that fraction. So that cancels there. This gives me x, y plus 2x equals 2y. Okay. So now I want to get my y's on one side and my x's on the other, so I'm just going to flip this. So minus 2y minus 2x. So now we have xy minus 2y equals negative 2x. And I'll come up here with this one. So xy minus 2y equals negative 2x. I see that we have y's in common on both of these, so I can factor a y out of that. So that gives me y times x minus 2 equals negative 2x. And now to get y by itself, I just need to divide both sides by x minus 2. And so I get y equals negative 2x over x minus 2. This is the true inverse function. So this would be f over g to the negative 1 of x equals negative 2x over x minus 2. Whoops, x minus 2. And of course we should find the domain. We already know this one is x cannot be equal to negative 2. This one, x cannot be equal to 2. And something to keep in mind, when we were talking about inverse functions, we said that the domain of the original is the range of the inverse. So that means that when we flip the x's and y's like we did over here to fix this, we also need to flip the x and y on here. So this needs to become a y as well. So y cannot be equal to negative 2. And vice versa. This one, if we wanted to assign it to here as the range, we would say that y cannot be equal to 2. So let's see what this looks like on our graph. So my original function is 2x over x plus 2. And then our inverse function we found is negative 2x over x minus 2. So I've got these in the calculator. And let's go ahead and see what their graph is. Okay. Now what's happened, it's kind of hard to see with this example, but they've been flipped. So see how this blue line is kind of tucked into the corner, and then there's a blue line opposite of it that crosses through the origin. The red is exactly the opposite. The opposite corner from this one has this little red line tucked in the corner. And opposite from it, it has a red line that goes through the origin. So if we take the blue one and flip it across here, so across this diagonal, if we take the blue and flip it, then it gives us what we have for the red. These are inverse functions. The y's and x's have been exchanged, which we should be able to see here. Okay? Now the other thing I want to point out is the domain and range. So like this first one, blue one, we said that the domain was that x cannot be equal to negative 2, and the range is that y cannot be equal to 2. So if we graph this, let's see, y2 is right here, and I'll just go ahead and put in a line there to show it. Y cannot be 2, so 2, y equals 2. So this pink line that I've added here is where it cannot cross. As we can see, it's really close to it. It tries to get really close to there, but it can never quite cross that line. And then the same is true for x. So we said x can't be negative 2. I've got negative 2 right here. Vertical line right there. It does not cross it. So you can see the domain and range in your graph. And you can see how these are inverse. Literally, they are flipped. One is flipped to the other. Any questions? None? Okay. So that will do it for today. Again, we don't have many days left, and this week is really going to be the only week that we have lecture. After this week, I'm mostly just going to give y'all time to work on Hawks and get things done. And like I said in the email, if you are registered in the in-person, the face-to-face class, you do not need to worry about attending the face-to-face class from this point on. Attending through the stream is perfectly fine. In fact, I have had one person all day in the classroom, and that was it. And that's perfectly fine by me. At this point with COVID how it is, I'd rather it be this way. All right, so again, I think that's it for today. I will see y'all later, and I hope you have a great day.